So this is a sampling question going over asking what's the most reactive and what's the least reactive here. And what we're thinking about, the reason this is difficult is just because there's the common names, and I'm not asking you to know this, but basically what you need to know is benzoyl chloride means it's an acid chloride, anhydride means it's an anhydride, propionate means it's an ester, and amide, OH, anhydride, chloride, acid chloride, amide, of course, means it's an amide. Now, it doesn't these aren't the right structures for these. It doesn't really matter. I'm asking for what's the most reactive toward nucleophilic acyl substitution. So all it's really asking is the carbon of the carbonyl group, what's the most reactive and why? Is that it comes back to that Mount Carbonyl, where the things at the top are the most reactive, because that carbon's the most electrophilic. And so this carbon, acid chlorides are more electrophilic than anhydrides, because the chlorine's a really good leaving group. It's also very electronegative, pulling that away. Anhydride, this whole portion right here is a better leaving group than this, because this portion could do resonance, whereas this can't. And an oxygen is a better leaving group than a nitrogen, because an O- is more stable than an N-, right, because of electronegativity. Also, this nitrogen donates more electrons, so that makes this bond, this carbon, less reactive, because a nitrogen is more likely to do resonance because of electronegativity as well. So you can get to this idea about Mount Carbonyl. This is like number 16 in sampling, so I'm not really worried about you actually knowing the names, just knowing see the end part, and then you can recognize acid chloride, anhydride, ester, or amide, and then kind of think about them based on that Mount Carbonyl. The most reactive things at the top, less reactive things going down, but using concepts we know based on electronegativity, resonance, or electronegativity.